Ansari, and I'll be giving you an overview of how to build an Android application where you can integrate a smart contract as well. So starting with, I'll give you a little bit about my introduction. When I started in my first year, I was an Android developer actually, and after doing Android development for 2 years, I got into Web3 and I started particularly with Solana, right? So this Venn diagram comes to like an Android developer and Solana developer. So that's where I started working in building a mobile application using Solana blockchain. And before that I was also interning at Solana Foundation and Hubble Protocol, which is the Solana DeFi protocol. I also did my MLH fellowship and was MLH top 50 this year. So we'll just get to it. So has anyone like made an Android application before? Okay, I see a lot of people, so that's good. Has anyone tried their hands with Solana development? Okay, that's great. Okay, so when we look at the mobile overview, like what all SDKs we have to build, first comes up is Solana mobile wallet adapter. It is by Solana Foundation itself, and it gives you transaction signing services. Let's say if you want to sign a transaction, it opens like wallet applications such as Phantom and Soulflare for you. Then we had a Solana KT library specifically for Kotlin, which was made by Metaplex. This has like more functions, like basically wrapping like a lot amount of code in single functions to make it easier. But still, there is like a lot of scope for improvement inside the SDK itself. So there was a starter pack created by one of my friends. It's a mobile app scaffold where like in the React side you have npx create React tab, so you get like a whole web page where you can just like when you're building for the first time, it will be really easier for you as it provides you transaction signing services. So if I show you the If I show you the mobile app scaffold, it looks like this. We'll also be using it today. So it provides you like connecting your wallet, then airdropping some SOL, signing a message, sending a transaction. So all these functions are already written to make it easier for you to develop and like remove a lot of boiler code for yourself. So moving back to the slideshow. So what we'll be doing, the dApps portfolio that we have is like using both wallet adapter and the Solana KT library to make things easier for us. And I did see like few people are still new to Solana, so what I'll do, I'll brush up some concepts real quick. And the first one being accounts. Everything in Solana is an account. Even your NFTs, your wallets, everything, even your smart contracts, which are called as programs, is an account. And they store data and they have like these statuses. If the account is executable, it becomes a program, which is a smart contract in Solana. And smart contracts execute transactions and instruction. And when we move on to how do we interact with these smart contracts, the word transaction comes up with. Like to write your program or smart contract and you deploy it on chain. To interact with it, you need to send a transaction to the program, with the program ID and stuff. So we have the transaction. It has three parts. Mostly you have to give them an array of instructions that you want to execute. Then second part, we have accounts which we need to read and write from. As I said again, accounts are like everything in Solana is accounts. There's program is also a special kind of account. Then we have signatures, so we're signing the transaction and stuff. We can have multiple signatures as well. And the last part is instruction. It's the smallest execution logic. When we write a program, we create small instructions that we want to execute, and then in the client side, we call these transactions to execute the instruction on chain. And the instruction basically has program ID. The smart contract we wrote after we deploy it to get a program ID. This way, it knows that we want to go to this program and execute the instruction. Second is account and the data. So, or any data which is related to that instruction is there in that and it's encoded. Now, let me just get back. Yeah. So, what we will do today, like I think so I gave like a quite introduction of what all concepts and keywords I'll be using to make it easier to understand. And if people are new to Android development, don't worry, I'll be using a starter pack, as I said, mobile app scaffold, which already has a lot of functions written for us. I'll explain how we can create an instruction object, a transaction object, and send it to be signed. So looking at like the first step, the setup will be, we'll look into the mobile app scaffold, we'll do some UI changes, we'll add the program ID, and the main execution logic part will create the instruction object, the transaction object, and send the transaction. These are like pretty quick steps, to understand how the development works exactly. So the challenge is, let's integrate a smart contract under 20 minutes. And I've like already written the smart contract. I'll show you, I'll give you an introduction of what it is doing behind the scenes. So it's a waffles app where you can just give a name of a waffle you like, whatever you like, and it will just add that data on chain. So it is something like that. Okay. Now, before we move on to this, to create the app, I've already written like the code snippets in like a proper manner with instructions if you want to go back to them after the workshop itself. So you can just scan the QR code. It's a Notion link where all the code snippets are there. I'll wait for a few seconds till then. I guess everyone is done. So when you open the Notion, it will be something like this. All the links are there, everything is here, so later when you go back to it, you can still refer it. Now the first part of building an Android app is you need a smart contract or a program. Now there's two ways. You can go, there's another Notion page which is Waffle Maker actually, the program is called Waffle Maker, where you can follow step-by-step instructions and create the smart contract yourself. But as today is mostly focused on Android, we'll just copy the program ID after we deployed it, I'll still show you around the Waffle Maker app actually. The instructions are already there. I'll show you what is exactly happening. As you can see, the create waffle, I'll just increase the font size. Yeah, the create waffle is an instruction, and what it does, it will have some checks like the name of the waffle should be like between 1 to 30, some pre-checks are there. And then there's something called as context, create waffle. This is basically we are using Anchor smart contract, right? And you need to define how the instruction will look like and everything, and that is the context. And what it is doing, we'll take a look at the context as well, which is below. Mainly, if you see there are three things, there's a waffle, there's an author, and there's system program. If we look at waffle, basically when we create the waffle, an account will be created and the data will have the name of the waffle, right? And second is the author who is signing this transaction or the instruction to be executed. And last is a system program. So basically if you like have this visualization here, system program is on the top of the chain and all the programs and accounts are owned by system program. So when we send this instruction, a new waffle account will be created, and for that we need system program. That's why it's added. Now looking into the constraints, it's written init if needed. Init is basically initialize if needed. So if the account already exists, just ignore it. But if it does not exist, then initialize it. That's why it's called init if needed. We mentioned who's paying for this account to be created. Basically, if you want to put data on chain, you need to pay some rent for it in Solana. So that rent, who is paying that rent is the payer or the author. Then we define the space, basically the space which will be required by the waffle account. We can't just have like unlimited amount of space, we need to define it properly. And then we have seeds and bump. Now to get into it, I'll give you a small introduction about PDAs, which is program derived addresses. So as I said, there's like accounts, and accounts have like let's say there's a wallet. It has a public key and private key, and the private key signs and everything, So if we create an account, new account, it will also have a public key and private key, and you need to have a key pair. And it's not feasible every time. Let's say I'm creating a lot of waffle accounts, like different accounts. You need someone to sign for it. So we can create an account which is a program derived account, a program derived address. So basically that account is owned by the program and they can sign on behalf of that account. So basically to create a program derived address like the public key or something, you need to pass some seed phrases, seeds as well. which will like put it in a function and it will derive that address. This way, on the client side, you can get the same address as well. So you know, okay, these are the seeds, and you need to pass them to get the address. So here I've used waffles and the name of the waffle as bytes. So this creates like a unique identity for the waffle, you know. And there's a bump. It's a little bit deep concept. I won't get into it right now. So looking at the instruction, we saw that it was doing some pre-checks. There was a context, and what is happening? This context, which is CTX, we are updating the value of the context. So the author of this context becomes the author who signed the transaction, and the name becomes the name that which was passed in the instruction. And then this is basically a macro to log messages on chain. So whenever the instruction is executed, in the log messages it will come that waffle is created with the waffle name. This way we verify if the waffle is created or not. Now let's get to the actual coding part. We already have a program ID. We looked into how the smart contract looks like. Now all we gotta do is write the code. So first thing is we need to set this up. Now we need to go to the mobile app scaffold. We click on use this template, create our own repository and git clone it. It's like a pretty basic procedure, and I've already git cloned the webpo so that it's easier for me and I don't have to wait for like internet connection for it to download. And as you can see, this is the mobile app scaffold which I've already downloaded. Yeah, it's in the app.
Can you say what the
What?
what is the program actually doing?
The program. So basically the program, whenever we send a transaction to the program and that transaction has an instruction which mentions a program ID, that program ID will be called. And if we send the instruction name such as create waffle, that create waffle instruction will have the name as well. So first it will check that,
Sending a message actually.
yeah, it is actually creating a waffle account, and that account has the name of the waffle, and it is also sending a log message. That's what it's doing right now. So this is the mobile app scaffold. I will run this for you so we can see how it looks like. And then, okay, let them let that go. Yeah, so if you're developing, you need to have Soulflare or a wallet installed, because eventually you'll sign the transaction and you'll need some souls as well, definite souls to sign the transaction. Let me see how much time is left. I guess it will build and then we'll look at the setup. So now looking at the Android code, first what we'll do, we'll add the program ID, you know. I think so it's started. Yeah. Okay. So this is a mobile app scaffold, and if you can see, if I click on select wallet, it will connect my wallet, which is in wallet as well. It will start. Let me see why it keeps stopping.
The program knows you are giving it and it is bound to crash.
It always happens at a workshop. Okay, I'll give it some time to load properly, and then I'll click on select wallet. Okay, I think so there's a problem. I don't know what's the problem is. I guess the mobile app scaffold got updated. I just cloned it yesterday. What we'll do, we'll write the code and then I'll run it for you properly in the end. So looking at the program ID, what we'll do, this is the program ID that I showed above. We need to add it in the local.properties file and then we'll do it simultaneously. I'll just open the one which was working yesterday. I just realized why it was giving error. So basically, this emulator doesn't have wallet actually. I need to switch my emulator to run this. Okay, so okay. This has already connected my wallet, and if I click on airdrop soul, it will airdrop me some souls as well. Okay, till then you can see there are a lot of new things. This is like the completed app actually, but I'll just run the old one, like the new one only. Now that I know that the emulator was not working. So like when you install the emulator, just see it has Google Play Store, so you can install the wallet as well. So this is the dApp scaffold. It has I guess two functionalities which work: signing a message, sending a transaction, and it has airdropping soul as well. Like last time when I clicked, it was 5.09, and like the airdrop happened, and I got 6 soul. I'll click it again. In Solana, you can just airdrop 2 souls per day, DevNet souls. So I guess it will do one more time. Till then, we'll start with the coding part actually. This is much better. So the first step, as I said, we need to add the program ID. I'll just copy this, and in the local web properties file, this. Basically, this file does not go to GitHub actually, just get ignored. I'll go to the Gradle step, and there will be a local web properties, and you just copy paste it here. Now to add it to the program, there is a Gradle file where you need to include this, this is where you can call it everywhere in the whole app. So in the Gradle.build, I'll copy this part as well. We need to go to the app one, and we need to copy paste it somewhere. Yeah. Outside this. It's calling the local properties from the file, and inside the Android part, we'll copy paste this part. This is just basics boilerplate code where you add the program ID. To be honest, you can directly add the program ID because no one can modify your program unless until you are the author. It's just me doing some extra steps for the code. I just realized it right now because mostly program IDs are not that scary to put out. So whenever we call build config.program ID, it will replace it, and it will be easier for us to update the program ID as well. You know. So the first part is done. Now we'll do some UI changes. We'll make it look like a waffle app, you know. And the first thing which we'll do, like a normal hackathon person does, is change the heading. We'll change it to waffle app now. And what you're gonna do, there's a REST file. We'll go to layout and fragment dashboard. Sorry, code actually. So if you see, this is actually a string which is stored at the strings.xml file already, and where it is, yeah, Solana mobile scaffold, and replace it with waffle actually. After this, we'll add some buttons as well. Like we need to enter the name of the waffle, and then we'll click on the button, and the transaction will be sent. So what we'll do, we'll add a button inside. We'll go to fragment dashboard now. Here we will add a button and a text box where we enter it. If I split the code, we'll have to add the code somewhere near here. I've added dot dot so you understand where we have to add this. I'll copy this part. and copy paste it here. Now I've mentioned some strings, but these strings do not exist. So below I've mentioned the strings as well. I'll just copy it. Go to strings.xml and paste this. So the fragment dashboard will look something like this. I think so I added the strings. Oh, I have not synced the Gradle files. So whenever you make changes in the Gradle files, you need to sync it so it syncs with the project as well. So we have made some UI changes. We did the program ID. Now we'll actually do the code of creating a transaction in transaction object. And if you look at this, let me just see why this is showing string when it is not. So this button, if you see right now, looks grey, but when we ran the app, it's like this color. Basically, it's like a normal feature. If the wallet is connected, it will show green. So the user know it's like you can actually do something will happen when you click on it. So this is also like a normal scaffold which we'll add. First, we'll go to the dashboard fragment. If you go inside Java and presentation and UI, we have the dashboard folder which has fragment and view model. Basically, the UI part and stuff will write in the fragment, and the logic part will write in the view model so that it's not heavy on the app itself. We'll go to fragment, and there's a function called enable wallet. Basically, it changes the color of the button when the wallet is connected. As we added a new button, we'll wait, sorry, I didn't copy. As we added a new button, we'll add this as well, and for disable wallet as well to make it back to gray again. Now the button, when we click on the button in Android app, we need to write a function which will handle that click. So on view created, we will write this function which is binding the create waffle button. The button is named create waffle button, and it will call this function which is view model. Basically, view model is this thing, dashboard view model file, and it has a function create waffle. We have not written it yet. We will write it. So the moment I copy paste, it will show an error under the function. So under one view created, so as I said, the create waffle instruction will not be shown. So I guess till now everything is clear, like the UI changes and program ID, right? Give me 1 second. Now this is the function. We copy it. In the dashboard view model, we will write this function anywhere, maybe in it. It takes a sender, which is start activity for result sender, and a name. Name basically the name that you have entered. So this start activity for result sender. When you look into the dash scaffold, it has like added all the handle clicks, because in this function we'll be opening the wallet as well. So there's like a lot of things involved. If you go deep into that, you'll understand why the sender is needed. Now we'll also do check from our side, because it doesn't look good when it comes from the program that you have added a 60 letter waffle which they cannot take. That's why before we call the function, we add pre-checks where it checks for if the name is empty, it says name cannot be empty and name cannot be longer than 30 characters. Yeah, now the final one, which I've been saying again and again, will create a transaction. Now we'll do the transaction. This is like a really long code, and what I'll do, I'll copy paste it and I'll go part by part what each thing is doing. You know? Okay, we'll copy this and we'll paste this. And what we'll do, we'll close all the functions from above to understand. First part, it is doing Solana.value. So Solana is a Solana object, and we add underline which makes it live mutable. So we can make it, we can mutate it live and it will be fine. We check if the Solana client exists. Then what we do, we launch a coroutine, because we'll be doing some network calls in this, and you need another thread to do this. And after that, the next function is get latest block hash. You need a block hash to be added in the transaction object as well. So what it does, this function is already written below by the scaffold. You can look into it what it is doing, and so basically we'll get a block hash ID and then the actual code will run. I didn't realize it was this blur. We'll go again. So Solana, we'll check for the value. Then we'll see, we'll launch the code routine. Then we'll get the latest block hash. After that, when the block hash is received, there are like three options: is resource success, loading, and failure. We'll obviously go to the success part because that's where the next step will happen. Then this function, basically what happens, this sender object we created, in this part of the code we'll be calling the wallet. So we need, this function does something where you can open the wallet, you can come back and everything will be handled properly. You know? First thing, we do a double check if the wallet is connected. Like even if the button color was green, maybe sometimes it was not, and that's why we're doing a double check and we're checking everything is connected. And this is the main part of the code, this much part. Instruction, transaction, and sending the transaction. This instruction function I'll write again. Let's say I wrote the instruction, I got the instruction back. Now my next step is I create the transaction, I set the block hash which we got from the first function, and I add the instruction. This way I can add many instructions, like more than 2, 3. And a transaction is atomic. By atomic, I mean, let's say the first instruction got executed, but the second or third failed. So the whole transaction will fail. It's not like it will do half and it will return. So transactions are always atomic. Then we set the free pair, basically the public key, and this use case in the scaffold, it's our wallet ID actually. It's stored properly in the proper classes as well. So you don't have to like do a lot, there's like a lot of boilerplate code involved. If I show you a glimpse, these all files such as DI, remote, repositories, DTO request, these all are handling everything for us, so that what we do, we just write a program ID, we create an instruction object, transaction object, and we send it and we forget. It will open the wallet, we don't have to think like, oh, because this involves a lot of, like I've seen the person who made this, like struggle with it for 2, 3 days, just trying to figure out so many things. So this makes it really easier. And the code which I showed, the whole code, this is actually signing a transaction code where I just replaced this much part of instruction, transaction, and sending the transaction. So after I've added the free pair, now transactions in a wallet, we can send multiple transactions, like multiple instructions in a transaction and multiple transactions as well. So right now I only have one transaction and I will serialize it and I'll make require all signatures through. And after that, it will send the transaction. This is also a function written in the mobile app scaffold which is sending the transaction for you. And then it is handling it. Like if it is success, it will log. If you see below, everything is like handling the errors and success with log messages. So even if the code looks too big, the main part is a little bit small. Now this was the transaction object. Now the last part is this instruction object which we need to create, you know. And yeah, hopefully it is the last one only. Now I'll get back to some theory as well. When we write a smart contract and when we deploy it, we get an IDL. But IDL is like a JSON file actually, which describes the structure. And you look at it and you understand how you're gonna create your instruction object. Now, if we had gone like written the smart contract ourselves, we could have seen the IDL. But as I have already created it, this is how the IDL looks like. You can see it mentions all the instructions that are there in the program. First one being create waffle, what all it contains, all the accounts like waffle account, author, system program, and arguments such as name, like this is like the name of the argument and the type of argument. It's not name. Then we have the accounts that we have. We have a waffle account which takes two things actually, an author and the name of the waffle, and error codes as well, and the address of the program. What we'll do, we'll look at this and we'll write our instruction code. So this is how the instruction code look like. I will copy this and I'll add this function somewhere above this. there's like two libraries which we are using and both have their own functions. I gotta see which one I imported. Just give me a second. This one's a bit one. This is not a bit one. For wash, I will see. Never imported wash before. Yes,
You need to resync to Gradle or something.
I did resync the Gradle, I think, so I'll just do it once again. It's not detecting the program ID. I don't know. The Gradle site is not accessible. I'll just stop that. Okay, for this, yeah. So basically, till I figure out why the program ID is not being detected. If it is not detected, I'll just add it like a normally copy paste. Till then, what is happening will look one by one. So, I guess after I run the code for first time, it will find the program ID for me. So first thing what we did is we will derive the program address, and before we do that, I will once again go back to what an instruction looks like. It has three parts: the program ID, the account, and the data, right? So first of all, if you see the accounts, I'm adding this in a mutable list of account data. The public key of like the program ID is there, the account list is there, and this is the data. Now the data is an encoded format. You can't just send like a string or an object or something. You serialize it using Bosch, and then the function is already written. And there you mention the instruction name, which was a create waffle. Because when we call that program, it will look for that instruction only. Because you can have multiple instructions in the program, and this will just be the arguments that you are passing. Now the arguments need to be serializable as well. This class we will write below will annotate with serializable, and it will mention all the arguments that are involved, which is the name. Okay. I will copy this and I will add this below. There is so much code involved in this. So everything is done. So first what we did, as you remember, the waffle account was a PDA, and you need to derive that address as well. So here, if you see this function, give me 1 second. We're passing the same seeds that we mentioned, like the waffle name and the name of the object. So the address we create here, it will create the address at the same place, and it will match if the accounts match, right? So if you see account meta, we added waffle address, we added the R address, which has the author, and the system program ID we added. Now there's something mentioned that is signer, is writable, and everything. Let's look back at our ideal and what it had. It mentions what it is, it's mutable. So basically you need to mention if this account you want to edit or not. So if we want to, because waffle account, if you see in our instruction, we're editing its value, we're updating the name as the name that we create. So we need to make it true. This is not signing the transaction, so it's called. Author is signing the transaction, it's mutating as well because some fees will be taken from author's account. And system program is doing neither. It's not mutating, it's not signing anything. So that's what you need to mention. You need to be really considerate about this because if there's like some mistake here and there, it's like always some error. Like you'll get a lot of errors. So always look at the idea that you get and you can write the account metas for yourself. And what we'll do, everything is done now. The instruction was created and it returns the transaction instruction object and that transaction was added and we already saw that the transaction was sent. Now we'll run this and let's go. It runs and we create a waffle. Emulators are a little bit slow to like run, so it will take a few minutes. What did I do now? No, I guess this is good.
Happens to the best of us. Happens to the best of us.
Yes, exactly. Okay, the code has run. Now, what I need from you guys is suggest me a waffle that you want to create. Like the first I did when I was practicing, I created it as nom. You can suggest me anything else. It should be like under 30 characters. What? Red velvet. Okay, we'll go with red velvet. Let's see if the code is like good enough for you to make the waffle. So here we'll write the name. Red velvet. Is it possible? I'll just do some amount plus. I don't think so we can do this here. But you understood that I wrote something. Now, this is so slow. Even the keyboard is taking like 10 seconds to go below. Create. So when I clicked on create waffle, it will open the wallet for me to sign the transaction. It is slow. First I thought I didn't click it. Now I will just swipe to confirm. And yeah, the transaction, what happened actually, now will be, I didn't click. I will create one more waffle. I didn't click on viewing the transaction. Dark chocolate. You already have the names written with you. This time we'll click on the view button quickly so we can see the transaction which just happened. Right now what I'm opening is Explorer where whatever transactions that happen, you can see them what exactly happened. And this handle was already written in the resource success, in the transaction success, it was already written that you need to show this below. So you can see this is the signature of the transaction. I'll just go below and see the program logs. First, you can see the system program was called to create the waffle account, and then my unknown program, which is V6, was called to do this create waffle. Actually, it's written create waffle, and there's a message returned which says waffle dark chocolate created. I'm not sure if you can see this. So what I'll do, I'll take a screenshot of this and I'll zoom in. I just realized you can do it from here. will create one more transaction because the link got expired actually. One more link please because I want to show the long message that it happened. Blue guys. Let me see now. Full blueberry something. Hardware. Okay, never mind. Like I think so. Most of you saw that it had long waffle blueberry. So let's go back to our presentation. We did everything. Everything is done. The coding part is done, and this is a waffle. So what we did, there was a smart contract. We took that program idea of a smart contract. We created an instruction object, the transaction object, and we sent that transaction, and we created a waffle. So, but there was one thing that you might have noticed that when I was sending the transaction to get approved, it was opening my wallet application. It was so slow, like I had to click and then do this. So what it does, it creates like user friction, and there's like a lot of infrastructure-wise, there's like a lot of development which we can do in the user experience as well. So during Web3Conf, it was a hackathon in Solana a few months back. We created a project called Organize where you can do in-app transaction. Basically, what happens? You click on the send transaction, and a bottom sheet opens up by our Organize wallet itself, where you approve the transaction, and this makes it more friendly, for the developers as well, and for the users as well, and for the people who are taking live workshops here, who need to wait for the wallet approval. So that's what we are doing, like simplifying and securing transactions on Solana Mobile. So this was me. You can find me anywhere on Anam Ansari, but if you're trying to reach me on Discord, it is a head062. And I also have a link where you can just scan my QR code and reach out to me with any doubts related to Android, Solana, or the Venn diagram or the instruction, like the common point, which is building a mobile app using Solana. Thank you.
So we still have time. So does anyone have some questions for Anam? Let's have a quick Q&A session. Solana devs in the house. Yeah.
Yes.
Have you looked into like how to upload stuff to the Solana app store? Like how can I create an app and like publish it as a development app?
I have not personally looked into, but I guess you'll have to contact the Solana mobile team on Discord, because I've not seen like a forum or somewhere you upload your things, and it mostly goes on Saga, so you need to contact them. Yeah, this one.
So, hello, as a former Ethereum developer, I'm working on that. What would your advice be for someone who's starting Solana for like a new change? If he wants to work on it as an intern, he wants to make an internship or a job, what would be your advice?
So Solana does have like a lot of opportunities. There's Super Team DAO. Like if you're a student, just go to Super Team website. They have like open bounties and lot of domains, like there's tech domain, there's non-tech. You can write an article or a thread, whatever bounties which are open. This can be a great start. But if you're looking like a more dev site, you can go into smart contracts. There's Trust and Anchor as well, and now Solana has also launched where you can write smart contracts in Solidity in Solana. I'm not sure how efficient it is because I've not gotten hands on myself, but I can say it's a good start for someone who's working with Ethereum and wants to get their hands dirty with Solana.
And what should be my entry point for someone looking for an internship in Solana? Like, what should be my in-hand resume and topics?
In-hand resume, like you can have some projects on GitHub. You can start talking about your work actually on Twitter. In Super Team DAO, you have Discord where there's a lurkers channel where you talk about your proof of work. Basically, there's everything related to proof of work. Whatever you build, you share about it. You say, okay, I built this. You promote it as well, so that if someone catches it your eye, they can talk to you. And there's also a job portal in the Super Team on page as well.
Okay. Anyone else? So then that's it. Thanks a lot for such an awesome and insightful session, Anam.
Thank you everyone. Like you have been like a really amazing crowd.
Cool.